In this video, I'll demonstrate the new pinning calculator for small format interchangeable cores available at keycalculus.com. It's totally free for unlimited use, no strings attached. You don't need to sign up or create an account, you can just use it. It works for A2, A3, and A4 systems, and it supports 5-pin, 6-pin, and 7-pin cores. You can use the link in the video description or go to keycalculus.com and click the link at the top of the home page that says Pinning Calculator. I'll do that now. I'll go to keycalculus.com, then click the Pinning Calculator link. To make it easy to try out, there is a button that will create sample keys for you. Notice that the A2 System button is already selected, so when I click the Sample Keys button, I'll get an A2 Control key, top master key, some people call this a grandmaster key, and 3 change keys. Change keys are also called operating keys or individual keys. There's also a field for optional cross keys. You won't use the cross keys field very often. I'll leave it blank for this example, but we'll come back to it later in the video. Now that I have some keys, I can just click the Calculate Pinnings button and we quickly get our results. We have a pinning chart for each of the 3 sample change keys. Below the pinning charts is a table showing all of the pin segments used in the 3 charts. For now, I'm going to close it, but we'll come back to it later when we generate a larger set of charts. Centered just above each chart is the change key cut. A core pinned according to one of these charts can be operated by its change key, the top master key, and any submaster keys the change key descends from. I'll include a link to another video that explains how submaster keys work. The pin segments are depicted as they would be positioned within the core, with the face of the core being on the right. This means that the tip of a key fully inserted into the core would be on the left-hand side, and the bow of the key would be on the right-hand side. The first column of each chart indicates what type of pin segment to use for pinning the core. For A2 systems, the pin segments that contact the key are called A-pins. These bottom pins are tapered. The upper B-type pins are not tapered. Now let's go back and try a different system type. I'll choose the A4 system type this time. When I click the Sample Keys button, the A2 keys are cleared out and replaced with sample A4 keys. Notice that each time I click the Sample Keys button, different keys are generated. You can edit the generated keys if you want to experiment. And once again, I'll click the Calculate Pinnings button to see the charts. Notice that this time the bottom pins are designated with an E and the top pins with an F, and that is also reflected in the pin segment summary table. You can generate up to 100 pinning charts at a time, so let's try that. I'll go to the calculator, I'll set the system type back to A2, but we won't generate sample keys, we'll copy and paste some keys from a spreadsheet. I'll reduce the size of my browser window so we can see the spreadsheet. First, I will clear out the existing keys by clicking the Clear Keys button. Then I'll copy the Control key and paste it into the calculator. Next, the top master key. And then all 100 individual keys. Notice that in our previous examples, the key cuts were separated by commas, but this time I put each key on its own line. Either way works. I'll zoom my browser window back to full screen and click the Calculate button. When you are planning to pin a lot of cores like this, the pin segment table can be useful for ordering pin segments. The pin segment table shows how many of each pin segment type would be needed to pin one core for each chart. For example, you would need 120 of the 0A pin segments, 100 of the 1A segments, and so on. And you would need 229 2B segments, 210 4B segments, etc. To print out the charts, click the Print button. If you don't want the pin segment summary on the last printed page, just click the red X to close the summary before clicking the print button. You can send the charts to a printer or save them to a PDF file. If you have more charts than will fit on one page, you might want to preview both portrait and landscape layouts to see which format requires the fewest sheets of paper. Occasionally, you may want some particular locks to operate only by an individual key, but not by the top master key or any other keys. This is easy to do. Let's go back to the calculator. To omit the top master key, we simply leave the top master key field and the cross keys field empty. This will prevent any keys except the individual key from operating the lock. The resulting pinning charts will have only 3 pin segments per barrel. Let's try it. I'll use an A3 system this time, but this works for all system types. I'll choose A3 for the system type and click Sample Keys. Next, I will delete the top master key. Then, click the Calculate button. Notice that each barrel of every core has only 3 pin segments. For A3 systems, the bottom pins are designated with a C and the top pins with a D. Just as we can omit the top master key, we can also combinate a core so it will operate only by the top master key. Let's refresh the sample keys, then I'll delete the change keys. Now I'll copy the top master key to the change keys field. When I click the Calculate button, we get a pinning chart for a core that will operate only by the top master key. We can also allow extra keys to operate a lock. Why might we want to do this? Let's say we manage an office building. Everyone in the building has a private office that can be opened by their individual office key. For the North Wing offices, we might mark the keys something like A1, A2, A3, etc. The East Wing office keys could be marked B1, B2, B3, and so on. And let's suppose there is a conference room for each wing. We want all the North Wing keys, A1 through A3, to operate the North Wing conference room, but not the conference rooms in other wings. Likewise, we want the East Wing keys to operate the East Wing conference room. We can accomplish this using cross-keying. Let's try an example. We'll use the same A2 system we used earlier. So let's set the system type to A2, clear the keys, and copy the control key and top master key into the calculator like we did before. For this example, we'll set up a cross-keyed core for the East Wing conference room. We'll use the B4 key for the conference room door, so I'll add the B4 key cut to the change keys list. But we'll also make that door operate by the B1, B2, and B3 office keys. I'll enter each of these keys into the cross keys field. Notice that I can also use spaces instead of commas to separate keys in a list like I did here. Now when we calculate the pinnings, we see that barrel 4 has extra pin segments to accommodate all of the possible key cuts used by keys B1 through B4. Each of the other barrels have just 4 pin segments. You must be very careful about using cross-keying because it's possible to unintentionally permit keys other than those you explicitly listed to also operate cross-keyed cores. Cross-keying can be convenient, but it does compromise security by making lockpicking easier, since there are more ways to align the pins on the operating shear line. It should only be used for areas that require minimal security. Don't use cross-keying until you fully understand how it works. That's about it. If you have questions, please ask them in the comments section, and I will post answers there.